Hello everyone, my name is David and this is part 2 of our video series on the solo growth models, and in this episode we're just going to go over a relatively simple problem to show what do we use the model that we learned to create in the last episode for. So this is going to be just a simple exercise. Whenever you have a solo growth model problem, certain parameters will be given to you. In order to keep this simple, let's assume that the following parameters are given to us. We know that technology, A, is going to be 100. We are given that the savings rate, sigma, is 0.1. The growth rate of the population is going to be 0. And depreciation is going to equal 1. And lastly, alpha is 1/2. Okay? And so what do we have to find? We're going to find what capital is in the future, kt plus 1 time period in the future, and what it's going to be 2 time periods in the future, right? So, one more thing that should be included is what is capital in the current time period, k0. Let's just assume it's 1 for simplicity. So, where would we go from here? Well, we're going to use the law of the motion of capital that we created in the previous video to solve this problem. So, if we recall, it's sigma times a k to the alpha plus 1 minus d kt, all of that over 1 plus n, right? So, let's just substitute the values that we have in there. This is the same thing as 0.1 times 100 times current capital, which we said was 1, to the alpha, 1/2, plus 1 minus depreciation, which is 1, times current capital, which is 1. All of that over 1 plus 0, like that. Okay? And if you solve this, just simply plug that into a calculator and you'll get 10. Right? So this is what capital in the first time period, t plus 1, is. But now, what is capital in the second time period, t plus 2? Well, we're literally going to do the exact same thing, except instead of putting 1 in for a capital, we put in the new capital, 10. And it'll be the exact same problem. 0.1 times 100 is equal to 10 to the 1/2 plus 1 minus 1, 10, all of that over 1 plus 0. And with that, we will find out that capital in the second time period is about 31.6. So that's capital per capita the next time period. And that's it. We could continue doing this forever, essentially, to find out what it would be in the long run. But in the next video, we'll be discussing, essentially, how can we find capital per capita in the long run, in what's known as the steady state, without having to repeatedly keep doing this for every single time period. Alright, thank you very much. If you have any other questions, please see your professor or come to the ASU Tutoring Center.